Okay, gang. In my last video, I mentioned something about how you can get from the acceleration curve to the velocity curve to the position curve, and you do it by taking the area under, and I think that bears just a little bit more explanation. So I have set up here a very similar situation. I'm going to have an acceleration of 3 meters per second squared. I'm going to start off with a velocity, to keep things simple, of 0 meters per second squared is v naught, and I'm going to move on to an x naught with 0. So this is following the green velocity and then the green parabola that I did in the last curve, and in the last video, and I want to show where they come from. So here I've actually gone ahead and I've scaled things, and I have here my acceleration 1, 2, 3, 4, and I've got the time. You notice how actually this is a really extended time. So each one of these ticks here represents a 2/10 of a second. So if we take a look at this and we say, all right, let's say at 1 second, we want to take a look at what happens from acceleration to velocity here at 1 second. So if I shade in this box here at time equals 1 second, well, the area of this rectangle, it's just 1 second times 3 meters per second. So t equals 1. And then so I do that. You know, a is always 3 meters a second. So a times t, right? Because that's a would be my height, t would be my base. That's going to give me 3 meters per second times 1 second. Or sorry, 3 meters per second squared times 1 second. 1 second. And that gives me, I'm going to write this as a delta v. That gives me a delta v of 3 meters per second. So if I plot that out, if I come on over here, that gives me that point. All right, well, let's just continue on. So now let's take a look and see what happens when we get to 2. So I'm going to shade in this. Now the trick, though, remember, since I'm talking about 2, I actually need to talk about all of this space. All right, so t equals 2 seconds. 3 meters a second times 2 seconds. Well, that's going to give me 6 meters per second, right? 3 meters per second squared times 2 seconds. Now if I go to 3, well, it's going to be 3 times 3 is 9 meters per second. So I can go ahead and I can plot these out, and pretty quickly you should see what's building up. That we are getting ourselves a nice, simple line. So here is that green line that I did in that last video, but with actually a couple of those points plotted in. What I'm going to do is I'm going to take this same idea and I'm going to use it to generate my x line, my x curve rather. So if I break this out and I go, okay, well, what I want to do is I want to take a look at this area. Okay, let's give this slashes like that. So what I have here as an area, well, it's a triangle. So of course my area of a triangle is 1/2 base times height. Okay, so well, my base here is time. My height is the velocity. Okay, so that's 1/2 times time, there's my base, times the height, which is velocity. But wait a second, my velocity, I actually have an equation for that line. V naught is 0 plus at, so really my equation is V is equal to a times t. Oh, so what I can do is I can actually just go ahead and write in a t. And I can combine this up, and I get 1/2 a t squared. So I can go all the way back to my acceleration, and I can do it that way, or I can use the velocity. So let's use the velocity and see what kind of a grid we get like this. So if I say at time t equal 0, here's t, and we're going to do velocity, and then we're going to do velocity times time. Actually, 1/2 of that, okay, because I need to get this. So when t equals 0, well, velocity is 0, so that's 0. So that's pretty boring. When t equals 1, okay, I have 1 second times 3 meters per second, and then I got to take half of that. So velocity is 3 meters per second. So 1 times 3, the half is going to give me 3 halves meters per second. This will just be meters, actually. Let's look at what happens here at 2. I'm going to stick with the pencil. I'm going to switch the direction. Right, so we have that now. So when I'm here at t equals 2, velocity is 6 meters per second. So what we're going to do, 2 times 6 times a half, 6 meters. All right, let's get one more. Let's go all the way out to 3 seconds. Let's do that. Go all that area there. So my base, my t, is 3 seconds. Okay, my height here is 9 meters per second. All right, 3 by 9 is 27, but I need a 1/2, so that is 27 over 2, or 13.5 meters. Okay, so let's come on over to this, and let's actually count out and plot what we're going to need here. So I'm going to go ahead and count up. 1, 2, 3, 4, 5, 6. We're going to need that one. 7, 8, 9, 10, 11, 12, 13, and 14. So really we're going to need that point, and we need 1.5. So if I come along and I plot these, we're going to have 0, 0. We're going to have 1 and 1.5, 2 and 3, and that's supposed to say 3 and 3 and 13.5. So now I can actually draw a better parabola. So starting with a 0 slope and working our way up. Oh man, okay, that's horrible, but you get the idea. So there's my position time parabola. So another thing you might have heard me say is that if you go backwards, it's the velocity is the slope of x. Well, I'm going to show you that in the next video. It requires just a smidge of calculus to understand. But don't get worried, because all of this, that was calculus too. It's no big deal. I'll be back.